My damn tripod over. My little mini tripod. Yeah, we're gonna do the old handheld. Okay. All right, so that's the impeller. Okay, that's the impeller. Okay, so where are we at? Well, in this diagram, okay, I'll just use this because this is even a GE version of this. All right, so we just went through the impeller. Okay, great. Well, the next thing up here, okay, is the fuel heat exchanger. Okay, great. So let's take a look at that. All right, you all seen this before. All right, fuel heat exchanger. Fuel goes to the center, goes through the tubes, comes out the opposite end here. Okay, so this goes up inside here. Goes up inside here. Okay, just like this right here. There it is put together. All right, the fuel comes in here, goes out over here. Remember the oil comes in here. All right, we heat the fuel with the oil, comes out the other side. Get the bypass valve that sits right here, thermostatic bypass valve. Output of the oil going up to the bearings. So this is our fuel. We melted the ice in the fuel. Okay. Well, why do we do that? Well, according to this diagram and the rest of them, you melt that ice to get to the filter. Well, right here's the filter. But this one here, when I pulled it out, I was like, oh, this is old. All right, because it's not supposed to be paper. It's supposed to be like a wire mesh inside there. All right, so yeah, this is kind of an old one here. All right, there's the relief valve for the filter up inside there. All right, this is a Pratt Whitney. That's a very typical Pratt Whitney relief valve on a filter. We saw this exact same thing on the oil filters. Okay, I just screws up on here on the bottom. And just screwed it up back in the housing. All right, so that's a filter. Okay, then great. All right, now we got the impeller. Now the impeller is driven off the high pressure pump through this gear assembly. Okay. All right, so this little gear sits in here. This sits over this housing as such. Okay, so it goes down like that. That's where it's this way. And this gear here, sits something like this. Something like this. So that's going to sit on just like that. And then this housing goes over top of that, and then all right, so when the input shaft is turning, the output shaft is also turning. Okay? Right now I don't have it fully engaged. I will though. Okay? All right. So, low pressure pump, heat exchanger, filter. Okay, now according to this diagram, we go right to our high pressure pump. Well, here's our high pressure pump sitting right here. Remember, the fuel pump is driven off the accessory gearbox. Okay, here's your input shaft off your accessory gearbox. There's your high pressure pump sitting right there. Okay, there it is being turned by the accessory gearbox. Okay. All right, gear type pump. Everything you know about a gear type pump is sitting right here. Okay. Now, because that gear type pump is driven off the accessory gearbox, right there, this is where this shaft right here comes into play. That goes in this one here. All right, and you can see how that would feed into this gear here. Oh, I gotta put that housing back down on here. Okay, and then that would feed into this gear on this side, feed it down here into that impeller. Okay, so this is the high pressure. This is the fuel pump on the engine. Okay, great. All right, so we've taken fuel All right, low pressure fuel, fuel heat exchanger, filter, high pressure pump, and now we go to our fuel control. That's this over here. All right. So this is what the whole pump housing looks like put together. All right, now fuel control. All right, everything we know from this basic diagram is inside this unit. Now, how do we know which is which? We don't, because that's what it looks like on the inside. Yeah, not a whole lot we can tell what's what and what here, but we can say that right there is your throttle input. Okay, they call this a droop cam here. You can see where this is rides quite a bit in this area. In fact, it's kind of worn out, in fact, because of it's been riding there. Okay. This will have effect onto the input from the P3 on it. Okay. Right here, this is your governor. That's your governor input right there. Coming from your accessory gearbox. Okay. Now, this is your throttle input coming from your power levers up on the flight deck. Now, the pump is not clearly marked on what is your PS3 and your input from your inlet. Okay, there's not a, we got a whole bunch on here, but the closest I can determine, there's a fitting right here. That was your PS3 on this one here. Now the PT2, I got the fuel controls completely put together over there. When they took this upper housing off, I don't know where it's at, but that's a complete fuel control over there. But they do have this marked. They have outlet here marked, and they got bypass marked. Now, what do you think the bypass means? Anybody remember that about the fuel control?
Pressure.
It sits right there. What do we call that?
Pressure regulator valve.
That's right, pressure regulating valve. But here, they call it a bypass. It's doing the same thing. Okay, because it's maintaining a constant differential pressure across that fuel metering valve. All right, it's relieving the excess out here back to my inlet side of my high pressure pump. Okay, so all that's happening inside here. Okay, all right, so all this unit right here, although typically they'll mark like a PS3 or T2 or something like that on the fittings right here. Unfortunately, they did not do that on this particular model. Okay. They do have our trim adjustments on this. Okay, you got idle and then a part power or partial takeoff thrust setting here. Okay, which way do you always make your adjustments? Increase. So if your idle is too high, you decrease the screw until your idle comes into your set idle for the day. All right, once you establish that, then you crank it down an additional 10 clicks, and then you rotate it back up. That way you're always doing your adjustment in the increased position. Okay, same way with your part thrust setting right here. If you got adjust downward, you always go below your target and then bring it back up to it. That way you make sure you're always, the trimming is always spring loaded to the increased position, not decreased position. Okay, so we talked about the two trims. Talked about, there's a lot of mechanical motion in there, isn't there? There's a lot there to wear out, isn't it? Now you can tell we're an EEC with electrohydraulic servo valve will eliminate all of this. A lot more reliable. Okay, you can't even see the governor deep down inside this thing. Okay, all right, so we've gone over this basic diagram and then I can actually see part of this. Okay, now we bring fuel out of this and then we bring it to a pressurization and dump valve, which is this unit here. Where here you have your input. Unrestricted here, okay? This is your primary and this is your secondary here. All right, now on the primary side, it just had a filter. They put a filter on this particular one. And that's what went in on this side here. But the P&D side here, all right, this was inside it. All right here. Sit up inside there. Right, the spring. All right, that right there is the P&D valve. All right, that's slid up inside this housing. Good to go down there, nice and smooth like it did before. Yeah, if you get it going in there crooked, it won't go in there. All right, and this housing here goes on top of that, and it's adjustable. You can't adjust that cracking pressure on this at this time. Okay? All right? So that's your secondary fuel flow. I'll get that back out there sometime. All right? So it comes out of the housing. All right? So you got your spring adjustment here. Okay, you got that goes up on the side there like that. Oops, that missed one part. This part goes up inside there. That goes up inside there. All right, and then this goes up in here like this. All right, so when you get to a preset pressure, it opens up, allows secondary flow to happen. But this happens at a preset pressure for that to happen. Okay? All right, so that's the pressurizing valve. We also got a dump valve right here. Okay, so we have our inlet, all right, our primary, secondary, and of course our dump. Now the dump here has been blocked off, so that was that right there. But on the dump, all it is just a spring-loaded valve. Okay, so let's take a look at the dump here. So when you shut down your engine, you bleed down your manifold. There's your dump valve. Okay. There's the inner sleeve of it. Right there. Okay. Alright, so it's being held closed. Okay, on that one. Go there like that. Okay, so this is your dump. Alright, when this opens up, it allows the fuel to drain back to the, in this case, to the ground or to a canister. Okay, you can see your two flow setups right there in that servo. All right, you can see your two flows here, and there it is, open. All right, right there's your drain. Okay, so there's your two positions. So this is how a servo works anyway. Okay, any questions so far? We're doing good. All right, so we talked about the pressurization. All right, of it. All right, we look at this what this portion is here. We looked at the dump. Okay, so this is a 2-manifold engine. Because of P&D, the flow regulator, which would be this right here, this would be your flow regulator. Okay, or flow, I'm not regulator, flow divider. Flow divider, there we go. All right, but here on this end they call it a pressurization valve. Same thing. Okay, all right, and we talked about the dump valve. So we see the P&D here. All right. Okay, now you guys seen the fuel pump, the low pressure, high pressure, heat exchanger, filter, fuel control, P&D valve. Any questions on this so far? Am I doing good? Is it kind of bringing things together or? All right. Okay, now, this is what the whole fuel control looks like over here. And this is what that fuel control looked like before they had a major dissection on it. Here's your input over here, because you got the 2 idle stops on this. Okay. So you can see your cable. This apparently must be your cable input coming in here. coming on this side here. All right, now again, they took this top off. And I don't know what happened to it or whatever came about it. But here, this goes to I'm assuming this would go to a variable stator vane actuator, because it comes back here to the field control. I'm not quite sure about where this field control came from. But there's my N2 gearbox input right there. So that's going to be driving the governor right behind this housing right here. Okay. Now again, it's not labeled where the PS3 would come in. Usually they have like in a casting a PS3 input or something like that. They don't have that on this particular engine. So I can't tell you which one's which on this. Okay. All right. Other than a rough guess, this looks like it could be the PS3 coming in. It's in the right position for it. But again, I'll be just guessing at that point. Now this is technically your bypass valve here, because you can tell by the housing there's a spring located right behind here. I imagine if I took that out right there, I'd probably see the bypass valve set up right there. Okay. All right.
Would you ever have to like open up one of these cases and
No,
maintain it?
not on a line environment. This goes back to an overhaul shop, and they take it all apart.
So
At that, this is beyond our level.
This is like MRO then.
Yeah. Yeah. Okay. All right. Now let's take a look at something. I think it's this engine here that has it. All right. This engine here. Come on in here. All right. Okay, now this engine, I can safely say this station right here we are. What stage of this engine are we at?
The diffuser.
The diffuser. So what station are we at?
Pressure.
Station number.
Oh,
3.
3. All right, so there's a tap off. There's my P3 line right here. Right there. If I follow that down, it comes right down here, goes right to the field control scene right here. All right, that's your P3 sense line right there. Okay. Now, that is our main fuel metering sensor. We determined that. Okay, great. So what would happen? All right, this line is disconnected. All right. You go to start this engine with that line disconnected, what would be your indication up in the flight deck that that line is disconnected? What would you think you would see? A what?
Fluctuating.
Not fluctuating. That would be on the governor side.
You have issue accelerating?
Correct. So it'd be slow to start engine, wouldn't it?
Right.
Your starter motor would take the engine, and then the fuel flow would start to increase, but it's trying to maintain a good fuel 15:1 mix ratio, right? We can't do it if it can't sense it. So this would have poor accelerating and possibly what they call a hunk start. We haven't talked about that yet, where it never makes it to a start idle. Okay? It falls short and it will never get to that point. All right? That's a PS3 input problem. Okay? Now what happens, let's say this line came disconnected at altitude. How would you know then? First of all, if we're cruising, what are we running on in the fuel control? The governor. Okay? If that disconnected in flight, how would you know? When would you
Increased
know?
Fuel consumption.
No?
Accelerating.
That's right. You'll know right when you decelerate the engine. It'll be very slow to decelerate because it's still trying to maintain. It doesn't see the PS3 pressure changing, so it's not going to respond to your adjustment on your throttle at that point to decelerate. So it'll be slow to decelerate. All right? It'll be very long for it to come down. It doesn't see it.
Do it from the inlet sensor though?
All right, that's a bias input that makes a small mute adjustment into it. Now, when would you really notice this line right here disconnected? When you go to
Shut down.
accelerate it.
Oh.
It'll be slow to accelerate. That's a PS3 problem right there. Okay? Now what we used to do, all right, and I'll show you out there in JT8, we used to disconnect it here and at the fuel control. We cap off one end, we hook up shop air to it, and leak check this line to make sure that the line didn't have a leak in it. All right? Because we know we can't do too much inside the fuel control. We got to do a process of elimination because fuel controls are very expensive. Okay. All right. All right. Then our fuel control also has, on this engine, it has pressure here, because here's our inlet. That pressure line goes right to the fuel control. On the other side, this is a temperature sensor here. Okay. Now, this line used to be able to hook up to it. Well, it's no longer hooked up to it. It's been kind of mechanicized. All right, that's a helium-filled tube. So our temperature would change, and that helium pressure would change with the temperature. That would have an input into my fuel control. So this engine here, I had temperature and pressure input into the fuel control. But that's just a small bias input into the big input from the PS3. Okay? All right, now up here. All right, so we determined that the PS3 is fuel metering. Okay? Come on back over here so we can see this. All right. How many manifolds are servicing this fuel nozzle?
2.
All right. So how many flow dividers do I have on this engine?
2.
One per fuel nozzle?
Nope. Just one flow divider. One flow divider, because on the primary manifold, we know when we leave the fuel control, this is the flow divider down here. It'll go to primary manifold unrestricted. But when I accelerate the engine, the secondary manifold gets pressurized. All right, so that flow divider, when it opens up, will now supply secondary fuel at that time. All right, so I have one flow divider on this engine. Okay, great. Now, knowing what you know about flow dividers, let's say the engine is at idle. Okay, you go accelerate it, but accelerate slowly. Okay, what could be your problem there?
Secondary flow?
That could be a secondary flow problem because you're not getting it. That's going to affect your acceleration rate of the engine. Okay. Now this has always been the problem here, and there's no real good solution to this. You got an engine that's poor to accelerate. How do you know which one's your problem? Is it the fuel control with a PS3 issue? Or is it the P&D valve not allowing secondary pressure to come in? You don't. The fuel control is very expensive to change. The pressurization and dump valve is very cheap to change. So what do you go after first?
P&D.
Yeah, go for your cheapie and see if that helps. There's no real answer to this. Now if that doesn't fix the problem, now you have to go after the fuel control. Okay? But again, do your process of elimination. Make sure your PS3 is not clogged up. Both the tube and back below this line right here, because it's a straight shot right into the compressor discharge. So you want to make sure that's unrestricted in there. Okay, see back below that to make sure there's no carbon buildup inside there, to make sure none of your sensors are a problem. Okay, and again, there's no real way of measuring in the line. There's no real way if you have a P&D problem for acceleration or the fuel control. Now, we kind of go with our best guess, and what we would try to do is, we know it's poor to accelerate, but decelerate just fine. Okay, what you can almost say that was a P&D valve problem. Okay, and we try to do our best guess that way. Has that always been the answer? No. Yeah, they end up changing the fuel control anyway. But at least you change something cheap first. Try to cut the cost down. Okay. Now, if the flow divider was located inside the nozzle, how many manifolds would I have then?
One.
One. Now, here comes the troubleshooting that. Let's say one flow divider didn't open. Would you know that? If you have 30 fuel nozzles, that means you have 30 flow dividers. If one didn't open, would that be a major effect on the engine?
Probably not.
Nope. So you wouldn't notice that right away. So each side has a plus and a minus to it. Here you got to maintain 30 flow nozzles. Okay? So if one fails, okay, it could be a progressive failure. But each one's going to have its own cracking pressure because none of them are consistently the same. You get them close, so each one's going to bring in at different times. Or you have one flow divider, you have better fuel management, but then if something goes wrong with it, it affects all the nozzles. One doesn't have the other. Whatever the engine manufacturer picked, that's what they go with. All right, so if you have a flow divider located inside the nozzle, you have one manifold. Well, we have two manifolds, so we have one flow divider down here, managing all of them. Okay. All right, how's everybody doing so far? Good?
Pretty good.
Is it kind of coming together for everybody, or you want to see some more of this? Okay, let's go look at a commercial. This is a military version. Let's go out here and look at these JT8s. I gotta fix my shoes for it. Okay. Come on in, you can't see it from the back. Okay. Fuel control. These are your inputs coming in from the flight deck right here. Okay. All right. That's your fuel right there. All right. You do have a shutoff. This is your shutoff one right here. Shutoff is on the other side on this one. Okay, so you have one input coming from the flight deck that controls these two inputs here. Okay, all right, and then you got your fuel shutoff, which is back here in the back. Okay, so you got your fuel shutoff on this one. This has been kind of mechanicized here, and it doesn't work that way. All right, now our PS right here, our PS3 is actually burner pressure. Because I can look at this engine. I know there's a long duct turbofan engine. I know that. So we're looking at the fan duct here. But looking at this judgment right here, judging this by this angle right here, what do you think this is right here? Diffuser. The diffuser. Okay, that must mean this has got to be the burner pan back here. I don't see the fuel nozzles because the fan shroud here has got them covered up. But that's my PS3 right there. Coming off the burner, because I know this is a diffuser. All right, that's PS3 right there, because it's a hard line. It comes down through here, down, down. All right, goes down through here, and comes right in across the front of it right there. There's my P3 input right there. Now this is a JT8. This is the engines I used to work on a DC9. Now you can see here, that's a long tube. Okay, you can have some serious problems there. So what we used to do, we take it off right here, and we cap at one end, take it off at the other end down here, add pressure, pressurize that tube to make sure there's no rub points along here that wore through the tube or cracked the tube. Right? If there was no cracks and it was holding pressure, well, we know at least the PS3 was working. In the front here, all right. All right, here's my temperature. No, that's my pressure. Here's my pressure coming in here. Okay. There's a hard tube right there. The hard tube goes right over to the fuel control. Okay, so that's my pressure. My temperature is right there. That's a helium-filled tube right there. Okay, so as temperature changes, the helium pressure changes, and that has an input into the engine. Okay, so this engine here is taking P12 and T12 into it. Okay, and P3. We know that. It's driven off the accessory gearbox. Okay. Now, since we're over here, so we see right here. On this engine right here, there's your P&D valve sitting right here. Okay, so if you look at that engine, if you were to walk over to the other side, this is your P&D right here. Although we don't see the fuel lines, again, they're inside the fan case, so we can't see them. So we have one P&D valve. All right. Now remember, the pressurization valve is known as a what? What's a better name for that we know by?
Flow divider?
Flow divider. Okay. And of course, the dump valve, when you shut down the engine, we drain the manifold off. Okay. All right. So let's go back to the engine on the labs and the engine. I'll talk about the dump. Just talking to Ricky about all this. Yeah, this class is getting abused. You know, guys in a class, out of class, on Zoom, off Zoom, don't have access to the lab. And my biggest downfall, I relied on this lab, and rightfully so. It's not really a downfall, but I used to lecture in the class, then we come out here in the lab and look at it. It was right here. So as we talked about it, it was all right here. Well, I can't do that now. I gotta group it up, because the way I used to do this class, we would all go over those parts over there on that table. Then I would bring everybody in one by one, and you explain to me how all those parts work on that table. Well, I can't do that right now. It's like, damn, I'm trying. Okay, the reason I bring you guys back in here is so we can see this portion, because now we talk about the flow divider. Okay, we talk about the sense lines for the fuel control. Okay, we identified those on this engine, so we know what we're dealing with. Okay, now we'll deal with those fuel nozzles. I don't have one here, unfortunately. I thought I had one in the back there,